This is part 15 and the last in a series in which I've been developing a replacement for the Fluke 9010A cassette drive. So this is the original cassette drive, and they were reasonably reliable and used tapes similar to this. The problem is, of course, that as with any type of tape drive, it's fairly slow, relatively unreliable, and the tapes were becoming expensive to obtain. So what I've done is develop a drop-in replacement. As far as the machine's concerned, it is a tape drive, it doesn't know the difference, and it plugs in exactly the same way and doesn't require any further modifications to the Fluke 9010A or the firmware in the Fluke. And it supports internal memory, so it's got memory built onto the card itself. It's 1 megabit memory, and it effectively replaces up to 8 of these. It also supports external memory cards that plug into a connector underneath a flap, and there are various switches inside to select the various banks and several other options, along with some status LEDs. So what I'll do here is fit this into the Fluke, show how it fits into the case, and then we'll have a quick look at using it, and then I'll just briefly demonstrate the memory cards. So when this is assembled, it's assembled like this, where you have the switches and LEDs on the back of the board. They pass through cutouts in the case. I will be making these plastic cases available, but they won't be cheap. It takes about 6 hours to print the top and lower section of these. I won't be making the files available, but hopefully there'll be enough information in these videos so that if you want to, you can make up your own. The way this is assembled is you have 4 fairly thin wires running between the board and the connector inside the module, and then the connector is screwed into the underside of the flap. The way I've got this arranged is it goes out through the side, and that's so that the wires won't be stressed and end up fracturing. It should last a long time like this. I've also included a hole in the back if you want to bring the wires out of the back, but that's not really the best way of doing it because it bends the wires each time. These 2 pillars here are for springs. So there's a couple of springs that fit onto the pillars, and that is to spring load the button that's part of the original Fluke, and this allows you to have a spring loaded button that pops up the top cover. So we'll get the Fluke case, and I'll show how this all fits together, and then we'll give it a quick demonstration. So the first thing, of course, is to dismantle the Fluke, take out the old cassette drive, and the only part of the original cassette drive that you need is this top cover. If you're making up your own unit, then it will fit on however you designed your hardware. On mine, it just fits on in a very similar way to the original tape drive, in that it slides on from the back and then it pops down over the outer part of this cover. So you end up with a system very similar to the way that the original Fluke was arranged, and it fits on quite snugly, and it also then acts as a stop to prevent the flap opening too far. And again, how you arrange this is entirely up to you. On mine, I've got it opening just far enough so I can access the internal connector along with the switches inside. So once you've got to this point, we need to fit it into the Fluke outer cover. So if we get the Fluke cover, I'll show how this fits in using another unit. So this is the way I got this one arranged, and this just slots into this space, so it's quite a snug fit. And I'll just flip this over, and so what we end up with is quite a nice snug fit, and of course the cover can be opened. To keep things as simple as possible, on the version I did, I arranged this internal printed part so that I could reuse the original screws that held the cassette drive in, and also the original button can be used as well, so this will fit into this original slot, and then the two springs I showed a minute ago go onto the pillars on this unit, and then they sit inside the switch and they spring load the switch. The switch is not directly connected, or the button's not directly connected to the flap on here. It's just when you push it down, you kind of automatically push on the rear edge of this and it causes this to open. So what we need to do then, of course, is just fit this into the correct location and line up these screw holes. The only other thing we need are 3mm spacers between the plastic part and the PCB, because there are solder joints protruding on the rear of the PCB, of course. So I'll get this screwed into place. The only thing we need to be careful of when fitting it is to make sure that the springs engage with the two posts on the 3D printed part. So I'll just get this slotted into place. So once this is slotted into place, then the next thing, of course, is just to put the spacers in place and then fit the screws. So the spacers fit one in each corner, and then the screws pass through the PCB, through the spacers, through the 3D printed part, and then they screw into the original holes in the Fluke. So I'll just get this screwed into place. Then we just pop the last screw in. I can screw these down. These don't need to be too tight, as with any plastic case. As soon as they stop turning and you feel resistance, that's tight enough. If you screw them down too tight, you're in danger of damaging the Fluke outer case, which of course you don't want to do. And that's now nice and firm within the Fluke enclosure. This is organised so that it comes down on the inside of this support, so it doesn't bind or get in the way of anything. And as you can see, we end up with an appearance very similar to the original. The button is of course now spring loaded, and we can use that to allow us to open this, and then this pops up and is held in position. I don't know how clear this will be. I'll just try and get a light down, and you can see that we now have the connector accessible along with the dip switches and the LEDs. So the next thing to do is to get the Fluke main unit over. We'll get this plugged back in and see if it actually works. Okay, so the next step is to get the outer cover fitted back onto the Fluke, and the cassette plugs back onto the original cassette connector. So we'll get the top cover, and it just connects straight onto the board. I'll try not to completely obscure what I'm doing, and it just goes on. Make sure it's not offset. There is a key on the connector so you can't get it in the wrong place. Push it all the way down, and then that's it. We're now connected back onto the main board, and all we have to do now is fit this back onto the Fluke itself. It's a bit awkward with the camera in the way, but okay, we have the unit plugged back in. Power it up. Apologies as ever for the flicker on the display. Powered up, pass its self-test, and we'll try and read the memory unit. And that has indeed read successfully. We'll just check that it has read the programs, which it has. So it appears to be working fine. We'll give it a few more tests. We'll try and write the data back to the tape, and that works fine. So what we have at the moment is the unit installed, so it's just the internal unit that we're using. No memory card fitted at the moment, and so that gives us the equivalent of 8 separate tapes, so it's equivalent to 8 of these. What we can do, of course, is open up the flap. I'll move the camera so you can see inside, and then we'll try using a memory card and see if that works as well. Okay, so I've tried to get the display and the cassette drive unit into the shot at the same time. It's hopefully you can see them both, but really it's the switches and the LEDs that we're most interested in here. So if we do a tape write, you'll see it go through the two-step process of writing the tape, verifying the contents, and it's doing that just to make sure that what it's saving to memory doesn't match what's in the Fluke and it hasn't made any errors. So we'll do that. And you can see it doesn't take too long. It takes a lot longer if we've got more data. So I'll select a memory bank with more data in it. We'll read that. And you can see that it does take a long time. This has got a full complement of data, so this is absolutely as much data as this unit can handle. So this is the slowest it will ever be, and you can see it's read that fine. If I pull up a program on the display, you can see that we've only got 5 bytes of memory left, and we'll try and write that data back to the tape. So it's in the write phase, and then it'll switch to the verification, read back what it's just saved, and if it matches, then it will give us a success message. If it finds any errors, then it will come up with an error. Okay, and that was successful. I'll switch back to the original memory bank and we'll read that. And you can see it doesn't take anywhere near as long. What we can then do is memory or write protect the internal memory contents. What I've done now is I've switched the write protect for the internal memory on. If we now read the tape, it will read fine. So that's worked fine. But if I now try and write the tape, you'll see we're getting a message that says write protected. Hopefully you can see that. I'm not sure if the camera can actually see the display from where it is, but I've got a message on the screen that says write protected, and that prevents you accidentally overwriting the internal contents of the memory. What we can now do, of course, which makes this unit far more useful, is use the internal, or rather the external memory cards. And these come in 2 sizes. I've decided to supply these in 2 different capacities. We've got a 128K, and that will simulate a single tape, so that's exactly the same as a single tape. And I'm also going to supply 1 megabit cards, and these simulate or have the capacity for up to 8 tapes. Of course, the smaller capacities are cheaper because the IC is a lot cheaper. And these just plug directly into the connector on the memory unit. And then if you want, you can close the flap and just leave it in there, or effectively transfer the contents to internal memory, then unplug it. So if we now switch the 3rd switch along to the on position, then this selects the memory card instead of internal memory. So if I now save the data, although we've got write protect on, the write protect switch in here is only for the internal RAM. If I try and write to memory now, even though write protect is on, so we can't write to the internal memory, we'll still be able to write to the external memory card. So that's been successful. We'll try and read this back, and again that's worked fine, but now we're using the memory card rather than the internal memory. If I switch to a different bank, we can now read that bank, and so we've now effectively read a completely different tape. And of course you can have as many of these cards as you want, so each card effectively replaces up to 8 tapes. If you're using the 1 megabit card, if you're using the 128K version of the card, then it works in exactly the same way, but it only has the capacity of 1 tape, and essentially it will just ignore the bank switches on the main unit. So whichever bank you select, it will always be writing to the same memory locations on the card. The bank switches only have an effect if you're using the 1 megabit card. So you don't have to do anything special in terms of changing the configuration depending on the card. Just bear in mind, if you put a 128K card in, then you'll always be overwriting the data whichever bank you select. And of course, once you've saved the data to the card, you can take the card out and put it somewhere safe, and you've got a permanent copy of your programs. You can have up to 100 programs on each tape, which means each one of these can hold up to 800 programs. And then if you want to, you'll notice there are some jumpers on here. Do not modify these jumpers. This one here, if you remove the jumper, these are just solder jumpers, so there's nothing physical to remove other than the solder. But if you unjumper this one, it will effectively write protect the card. So if you've got 800 programs or whatever and you don't want to ever change those, just remove this solder jumper and then the card will permanently retain the contents. Specification for these cards is 200 years retention, but of course I haven't tested that. I'm not that old yet, but it does mean that the data should be there pretty much indefinitely, as opposed to a tape where the tapes obviously do degrade and are quite easy to damage. So overall, this means that the Fluke becomes far more usable. If you want to use scripting, then you can do that, and depending on how many cards you have or what you want to do with the system, you can transfer data from one Fluke to another simply by taking the card, plugging it in, saving the data to the card, take the card out, plug it into your other machine, and then you can have an easily transferable method for moving your scripts around. I won't be adding any other interfaces to this. If you want to transfer your memory contents to PC, then you'll need to use the RS-232 that's built in. That's not really why I did this. This is meant to just replace the cassette drive and make it far more usable. I will be making these available now. I'll keep the costs as low as I can, but selling small numbers of anything invariably means that they won't be particularly cheap. Having said that, if you're buying one card, I suspect these cards are going to come out something like £11 each, but bear in mind that each one is replacing up to 8 cassettes. Then what I'll be providing is PCB and a programmed PIC. I won't be making the CAD system or the source code available. I'll just be supplying them like this. I don't really have time to provide support, unfortunately, for CAD files or support for compiling the code, anything like that, so I won't be making that available. So I'll be providing it in this form. I suspect it's going to come out something around the £35 to £40 mark for this. I'll keep it as low price as I can. For memory cards, as I say, I think the 1 meg cards are going to come out something like £11 or so each, and the 128K cards will be something like £6.50 or something like that. If you want, I can provide the PCB, the programmed PIC, an assembled cable. With these cables, because it uses a PCB to ribbon cable connector, just bear in mind, if you want to save some money, you can just strip the wire and solder it direct to the PCB, as long as you get the pinouts correct, of course. But I will be providing it in two forms, either just the PIC and the PCB, or the PIC, PCB, ribbon cable, and the printed parts. Now the printed parts will be quite expensive. As I say, it takes about 6 hours to print those, but it will include the connector. The connectors for the cards, if you want to source your own, these are just 2.54, 0.1 inch pitch. Essentially these are flat cable connector type connectors, just 4-way. You can get what they call dual wipe versions of this connector, and they are basically the same in terms of the pin spacing. The only thing that's different is they effectively have contacts for both sides of the card. I recommend, if you can, you use single-sided, and that makes sure that if you put the card in upside down, nothing untoward will happen. The way I've designed this is it shouldn't actually do any damage if you put the card in upside down, but I wouldn't recommend doing it or trying it. I have tried it and it didn't do any damage, but obviously, as ever, it's not a good idea doing that sort of thing. With the single-sided connector, then of course if you put it in upside down, then nothing's connected to anything, so it's never going to do any harm. Whereas if you put it in the right way up, then of course the connections have to be correct. The way I've made this 3D printed part is the connector's quite a tight fit, and then there are two screws holding this in place, and I would be providing this in this form with it ready assembled. But as I say, these take a long time to print, so they will not be particularly cheap. I'm suspecting I'll be having to charge about £40 for this assembly, plus extra for the PCB and the pick and cable. Overall, I'm guessing it's going to be somewhere around £75–80 for this collection of parts, and that obviously reflects the low numbers I'm selling and the fact that some of these parts are quite expensive. For example, these connectors are quite expensive. The picks themselves are quite expensive because of the fact it has to be a 5-volt pick. 5-volt picks are quite expensive these days, but it does give a very nice addition to the Fluke, and of course the memory cards aren't too expensive, especially when you compare them to a lot of people these days are trying to sell single tapes for £40 or more. So for 2 tapes you can get this entire kit. In terms of components that are required, it's a very low component count. Once you've got the pick, the only other thing you need are about 10 capacitors, a crystal, a 6-way DIL switch, 3 LEDs, and then you need the ICs, which is a memory IC if you intend to use the internal memory, and then there are 4 buffer chips, 74LS138, and then there's about 12 resistors, so not really very high in terms of cost. I'm guessing cost for the components for the board, not including the parts that I'd supply, is going to be somewhere around £4 or £5. I will be providing a bill of materials with the board, and it won't specify using IC sockets, but I do recommend using IC sockets, as I've done with the units that I've built, and it does make it easier to test and do any fault finding with should you have problems in the future. Having said that, you can just fit the components direct to the board if you want. I don't suspect you'll get any issues. I just prefer to use sockets these days. Okay, so that's it. Any questions or comments, please let me know. This is otherwise the last in this series. I hope you found it interesting, and anyone that wants to purchase one of these kits and upgrade their Fluke would be interested on any feedback that results in. Okay, so once you've got the unit installed, memory card fitted, you can just pop the cover down. It then looks exactly like an original Fluke. You can't even tell this unit's fitted, except of course you have access to some very fast internal memory. So should make the Fluke far more usable for scripting, and hopefully anyone that uses the system will find it of benefit.